Hey there, this is Krish. Hope you're doing well. This is video number 3 in the series of videos where I talk about performance optimization. So if you have not watched the previous ones, the second one and the first one, I recommend that you do so you get better context to this video. And if you haven't signed up already on snowpal.com, definitely check us out and consider doing so, and download the mobile apps from the App Store and Play Store. So the newest version, I think it's like 28 or 29, I can't remember the number, maybe it's even higher, should be out in the App Store like tomorrow. I just pushed that. You don't have to wait for it, just download the latest one and you can get the update tomorrow. Back to what I was going to talk about in the video. This is video number 3 again. In the last one, we went all the way up to the database and we identified the query that was taking more than a certain amount of time, right? So our target again here is we want to bring the API from 150 or 100 milliseconds down to 75 or even better, and we localized it so it took 20 milliseconds in our local system in the dev machine, and we want to bring it to like 15 milliseconds so we can extrapolate that and see the gain when we push it out into the cloud. Just a quick recap, right? Now the query, let's say out of the 20 milliseconds the query takes up 25% or 50% of the time. That single query that we're talking about, it took 10 milliseconds. Now we know we need to optimize that particular one, and it becomes challenging enough because you're talking 10 milliseconds and you want to make it even faster, right? 8, because those numbers extend, it widens as you go out to these various servers out in the cloud. Now you take the query and then you try to look at it and you say, okay, depending on what your database is, right, or whatever your query language is. Now you could be doing connecting to Oracle or Postgres or MySQL in the RDBM as well, or you could be connecting to Mongo or DynamoDBs and all of the NoSQL stuff. So depending on which one it is, sure, your query would look different, and it's going to be quite different from each other. But what I'm trying to say there is the way you optimize, even though you can try to spot an underlying problem more generically, because even though these databases are different between RDBMS and NoSQL, or even the various flavors within RDBMS and various flavors or various databases within the NoSQL world, there is a set of commonalities, right? You're storing data, you're getting data back. Sure, before you go into that language or that database specific problem, let's ask yourself if this query looks all right generically, right? Generically across all databases. What are those? What are some of the questions you can ask yourself? Okay, if the query is simple enough, right? If it's a complicated query, we can go to that one next. If the query is simple enough, it is not doing a whole lot of stuff, it's got a couple of attributes and you're fetching data back, you want to see if you have indices on those attributes, right? So if you're just doing by ID, the index is generally created. If the RDBM is the primary key is created and it already has an index, you don't have to explicitly create an index. I can't think of a database where you'll have to explicitly do it on those primary keys. NoSQL doesn't call them primary keys per se, but it's still the ID field is indexed by default. But if it's just that, most likely that's not the case, right? If you have a problematic query, then it's very likely it is not just going by doing a fetch by ID. So you might have other attributes in there. It could still be ID alone. I'll give you an example, but let's say we'll come back to it in a second. It's most likely some other attribute. Now when you're doing a query, whether it's a find or where by a number of different attributes, and let's say they're not aggregate queries, right, or function queries, if it's like Oracle or one of these RDBMS databases. Let's say it doesn't use any of that fancy stuff, but it's just querying based on a few attributes. Then the order in which you have the attributes, the composite index, let's say you have a composite index which is essentially an index with one or more attributes in them, you have to make sure that the order of those indices is actually correct. Otherwise that index may or may not get picked up. And again, these things tend to become specific to your particular DB, but I've seen in general that order most certainly matters. So check to see if that sequence is correct, because if you don't have it in the right sequence, then it's likely that the index did not get picked up. And you don't really have to speculate. You could actually do an explain plan. I think Oracle calls it explain plan. I'm sure a lot of them call it explain. I haven't touched the Oracle DB in a long time, but it's from my memory. Let's say if with Mongo, for instance, you just do when you're writing the query, you do a dot explain, and then it'll give you the plan. You can look at the plan, don't be intimidated. There's a lot of stuff that you may not understand and you don't honestly have to understand, but just look for a few things where is it doing a full collection scan, right? If it's RDBMS, if it's doing a full table scan. That means it's going against your entire collection to find those documents of interest, and that's not optimal, right? And your database provider might actually create alerts so you already know that, hey, you're looking at too many documents to find a few of interest, then something is not right. So you don't want it to do a column scan. I don't know if that's the right word, but a whole collection scan, sorry, a collection scan. You wanted to do an index scan, meaning you have created these indices and they're stored wherever it is, they're stored in the DB, and you're doing a lookup based, the database is able to do a lookup based on that particular index, in which case it should find what it's looking for quick enough, right? Now there are times when the optimizer may not pick up what you're looking for it to pick up, so you can force it by using a hint. But then if you start going down that path, which you may have to, but it's not step one, most certainly not step one or step two, because you're overriding the database choice of optimizer and then saying a choice of a plan, and you're forcing it to pick a plan. And again, each database does it slightly differently, so you have to, the devil is in the detail, but overall at the higher level, what I'm saying here should mostly hold good regardless of what your database is. So make sure, we need to make sure that the index gets picked up. So sequence is one of those things that's important. The other things, there are other items that come into play. Now again, if you have functions, like let's say in RDBMS databases, if you have an index on an attribute or a field and you have a function, like if the left side of your query has a function, then you'll have to define a function index. Otherwise, the regular index that you define will not actually get picked up when you have functions that are part of your query, for instance, right? And the query has to be identical. There's a lot of things that come into play. And similarly, when you're using a mapping layer, like whether if you're using Hibernate for relational mapping, or if you're using Mongoose to connect to Mongo as a node user, or if you're using like Mongoid, if you're a Ruby shop, for instance, doesn't matter what you're using. If you're using an object relational mapping layer or a document relational mapping layer, like Active Record or Data Mapper or one of those things, then you have to be careful. You have to be a little wary of it. I know people start out always using it, which gives you a lot of convenience, so you definitely do want to use them, but that's not a silver bullet, right? I mean, it's not a magical solution that's going to solve all your problems. If your query takes long, sometimes it may not even be the query, because you may not have written the query directly. You may have just called one of these methods in your ORM or DRM layer, and that might generate that will generate the queries, and maybe it does not generate the best queries, right? So if that happens to be the case, you want to override it by actually executing native SQL, right? Again, I just say SQL, but what I mean is native queries. So if you're talking to say MongoDB, for instance, you want to skip the Mongoose or the Mongoid layers and just execute the query directly. So then you know that the queries that are being picked are in your control, right? It's not essentially the mapping layer that picks up the queries, because they work fine when you're rendering pages, but if you're doing reporting and aggregation and charts and all of that cool stuff, you most certainly don't want to use these mapping layers, because they bring a lot of overhead to the table. Not only that, when the query gets executed by those layers, and again, I'll take one more example. I'm trying not to make this too complex, but the problem tends to become complex very soon. If you're using let's say one of these DRM or ORM layers to write your queries. Now let's say you define your class structure. How you do it in Hibernate is different from how you do it in Mongoose versus Mongoid, for instance. But regardless, if you have your object models defined and they live in a beautiful class structure, because that makes a lot of sense to you as a coder, as an API coder, which is how we like it, that's totally fine. But the downside of that is the queries that get generated may be impacted by those class structures. Now, to take a very specific example, in our case, we have pods and blocks and keys and different kinds of data structures. So if you took a pod, there are a variety of pods. So we have a teacher pod. If you're a teacher who's teaching a class and you're using the product, what you end up creating as part of the teacher service or the teacher key is a teacher pod. But if you're using it as a student, it's a slightly different kind of pod, the other side of the picture. Or if you're not using the teacher service in the product, you're just using the project service or the project key, then it's a different pod, it's a project pod. Similarly, we have other pods. So we have a nice class structure that implements this, right? So it kind of creates a facade over your backend collections and documents. So it's nice to deal with these objects. But what that means is when the queries get generated, there's a type attribute that Mongoid, for instance, would, for example, would add to your queries. And now if your index was just an ID and it was not on type, then you're no good, because it's not going to get picked up, because you're writing a query that says give me something where ID equals blah, but then when Mongoid creates the query, it's going to add the type, because it's a type called project pod, and it's going to ask for that particular ID. Now again, this is where you have lesser control because you're using these intermediary libraries, right, to connect. But what you have to make sure is, in this case, you want to use that type also as part of your index. So now Mongo is going to pick up that particular index, right? So this is a very specific example, but hopefully it conveys the message. There's a lot more to talk about here. Again, I'm standing on the other side, so I have no idea how long these videos are. Clearly, I know they're not very concise, but hopefully that helps you. So when you're using these intermediary layers, keep an eye on it. Just see if the plan that you're expecting for it to get picked up is actually getting picked up. Now, if you're writing a query, if you don't have a plan in mind, that's a different kind of problem, right? So I've seen this happen time and again, where sometimes you go write a query and you're hoping everything will be great, hunky-dory, and things are going to come back quickly, and maybe they do. Maybe they do, because some other magic is out there, but let's not rely on, right, on those types of magical things to happen. When you write a query, just have some sense for what kind of plan you want the optimizer to pick up. You don't need to understand the explained plan, because they differ from database to database, and the way the structure is different, what they tell you is different, so you have to understand that. And sometimes you're not a DB, or you're not you don't have enough time to spend in the database. Like I don't have much time, so I just look at it really quickly. If I spot something that's glaring, I work on it. Otherwise, I'm like, okay, it should be all right. And if you do it for a little bit, you have a sense of what you want to what you expect, and also you have a sense for what you don't want to see. And when these plans are when the plans are spit out when you're debugging, right? So now, just to complete the video, let's say we identified something and then the index was not there, then it's actually an easier problem to solve, because you can add the index, make sure you recreate the index. Depending on the DB, you have to do a few things to recreate that index, and once the index is there, see if the plan is different. If the plan is different from what was there earlier and it picks up the index, it's not doing a full collection scan, then you're good. You should see a gain already when you deploy this to your cloud. But if adding the index does not make a difference, then there are other things you have to look into. I'll probably end the video with just saying what one of those things is, which is the number of times you're making the call. So in our example, we made 3 calls, right, via either directly or through the intermediary layers. If not one of them took all of the time, between 10 milliseconds was split evenly between all 3 of them, that means maybe it's just the fact that you're going back and forth. The staking is probably going to take longer. So you want to somehow you can rewrite everything else that you have. Just take this particular API and override what you're doing elsewhere, so this does it slightly differently, and you make 1 trip to the DB and you don't make 3 trips to the database. And especially if you're in a loop, watch out, right? Because I've seen code where sometimes you're in a loop, you're iterating through a number of right, objects in a collection, and then one of those things ends up making a call to the DB, right? So what happens then is, even though it's 1 call, I said the number of API database calls, it's the number of times actually, right? Because even though this is 1 call, it's 1 call per iteration. And if you have your loop iterating 100 times, then you're going to the database like 100 times. And if each one of them took a fraction of a millisecond, it's still death by 1,000 cuts, because you made 100 calls. Now that's going to take 100 milliseconds or whatever that number is, right? So these are some tips. Hopefully some of them help you when you're trying to make these sub 100 millisecond optimizations. Now if something's taking like 3 seconds, you want to bring it down to like 2 or 1, that's a different problem, and it's a lot of times a much easier problem, because there has to be something glaringly wrong if your request took like 2, 3 or more seconds, right? Thanks for watching.